Hey, hello everyone. Welcome to Blackfeathers University. I'm Himanshu Singh and I'll be your trainer for today for this very important section of machine learning called as feature importance and selection. So here in this particular video, we will be talking about all the different types of methods that come under this domain with live coding in Python. So what is feature importance? That is the first thing that we must know. So when we are building a model, we have a lot of independent variables present in our data set. And there is something called as curse of dimensionality, which means as many models that are present, as many variables that are present in our data set, more the complexity of the models will become. So if we come up with an approach by which we only take those variables or those independent variables which are actually leading to some kind of uh, increase in accuracy of the model performance, then that particular part or that particular domain of data science is called as feature importance. So, suppose I have a list of variables, suppose x1, x2, x3 till xn, and I have a target variable as y. Now, out of all these variables, if I train my model, and I get suppose an accuracy of 75%. But instead of this, if I only take the subset of these things, these variables, if I only take suppose x1, x3, and x5, and using that, if I train the model and I got train accuracy of around 85% and validation accuracy maybe of around 80%, then obviously instead of having this n dimensional data, we can proceed with n equals to 3 and it's going to give me the best model possible. But obviously we cannot just randomly take the variables and check the model performance. So there has to be some kind of an approach using which we will be training the model and finding the best subset. So how we are going to find these best scores? There are a lot of statistical approaches which we will be using to find our importance of features. Now, why feature importance is required? So first of all, it leads to reduction in overfitting. So if I have a lot of variables and I'm training the model for suppose 1000 iterations, 5000 iterations, then what exactly happens is that the model learns too much about our train set. So I have my train set, I have my test set. So my model performs really good in my train set, but in my test set, it gets failed. So this particular kind of a problem is called as overfitting. So to solve this problem of overfitting, we generally use feature importance and selection methods. Second is it leads to more accuracy. So as you can see, with more number of columns or more number of features, we were getting 75%, but it got increased to 80 or 85%. And obviously reduction in the training time. So training a model having 50 columns and training a model having only 10 columns. Obviously the model having 10 columns will perform faster. It will train faster. And that is why feature selection and feature importance is again really very important. Now, coming to the methods of feature importance, we generally club them into two domains, score based methods and wrapper based methods. There is something which comes in between, which is algorithm based methods as well, which we will be looking. So score based methods are when we apply some kind of an statistical approach to find out whether the variables are important or not. So we just try to understand the data set and the relationship of the variable with the target variable. And based on that, we try to find out what features are important and what features are not important. When it comes to wrapper based algorithms or wrapper based methods, we actually pass an algorithm inside to find what are the best feature set. So that means the features that we will be getting as an output, these features will be specific to that particular algorithm that we have passed inside the wrapper. So these two methods are the major methods that we will be using. Again, if I try to explain you, so if I have again my columns x1, x2 till xn, and I have my target variable as y, if I try to find out the individual relationship of the variables with the target variable, and I provide some kind of a statistical score, and then the variables which have less score, that we remove from the model from the data set, and variables having high score, that we keep in the data set. So that will be our score based method. Now if I suppose train a model, if I suppose train a logistic regression, so if I train a logistic regression model, and based on that, if I try to find out what are the columns or variables which have led to best predictions, so that will come in the wrapper based algorithm. So we will be talking about both the wrapper based approaches and the score based approaches in this particular video.